Okay, so we're now moving on to question 4. If I could just align that, that's correct. Question 4. And you can see immediately from the diagram, but it tells us here that this is the human digestive system. So we've moved on in terms of topics and the part of the syllabus to nutrition, digestion. Let's take a look. And so we have the digestive system. So as we work towards the question, it's always good practice to look at the diagram first, work out what we've got. Of course, this is the esophagus. This is the stomach. Of course, you will be doing this very quickly in your head, but of course you could put little notes on the diagram. That's the small intestine. Right, okay, and then this part, okay, so we know this is the large intestine, but why is it pointing to the end? And just take a moment to realize that that's the rectum that's being pointed at here, rather than the colon, where the label would be in this area here, like that. So let's now go to the question, having done our thinking. In which of these parts is hydrochloric acid produced? So I'm sure that you've remembered that the stomach is responsible for the production of hydrochloric acid. So that would be B. So we need to have a tick on B. The others simply don't fit, and so we've got another mark for that part there. In which of these parts are feces stored? And so because we took a careful moment to consider this, we realized that D is the answer there. So let's tick D nice and clearly, so that we are awarded a mark for that one there. Now we're into another explanation question, so we're going to give a detailed account, possibly with a reason why. The liver produces bile. Explain the role of bile in digestion. Now this is a very common examination question, and the reason for this is that bile is not an enzyme. All right. So this is one of the key things that you should remember about digestion. Bile is not an enzyme, but it does play a role which is important to enzymes, and that is the source of our answer. Liver produces bile. Explain the role of bile. We're looking for 3 marks. Okay, so number 1 is, let's put this here, so it neutralizes, the neutralization of stomach acid. Now that's going to get you a mark, but if you link that to, let's make this number 2, if we link that to creating the optimal conditions for small intestine enzymes, then, or optimal pH, if you like, optimal pH, we could put that in there, couldn't we? There we go. That's going to get you, already get you two marks. But we have another function of bile, and we're going to put down that the keyword is emulsification. Sorry about the writing. Emulsification of lipids. Now you would be okay with fats and oils. Emulsification of lipids. Now let's see if we can make a stronger link to get an additional mark or to cover ourselves. This emulsification is to increase the surface area for lipases, or you might have said that it's actually taking large fat droplets and breaking those down into smaller droplets, again for the action of lipases. And so in doing so, we've learned all this information. I think we've got 1, 2, 3, 4, possibly even 5 things here, but we're trying to maximize our chance of getting 3. You've spent a long time revising this. Don't leave it in your head. Put it on the examination paper and let the examiner give you the maximum marks. The diagram shows the villi of the small intestine. I've got this diagram here, and the question is going to ask us to explain how the villi are adapted for their function. So the word adapted in this context means how are they specialized for their function. So let's think about what that function actually is. It's for the absorption of the products of digestion. So how are they adapted in that way? So if we look at the diagram first of all, we can see that the villi, the folds of the villi, increase the surface area for absorption. We could also have that, we notice here that it's only one cell thick. So it's one cell thick between that and the blood. And so that means that we have short diffusion distances, and that would mean fast diffusion times. Let's just put fast diffusion in our notes, like so. We also noticed that the blood, okay, so we could say something about the blood here that's very close. That's also going to give us fast diffusion. So if we just take a moment, we've got increased surface area from the folds, we've got short diffusion distances, we have the proximity of the blood. In the diagram, I don't know if you can see this, but also here we have the presence of the lacteals for the uptake of fats and lipids. That also improves absorption. And then things not actually shown in the diagram, but not excluded from our potential answers, is the recollection that the epithelial cells here, the cells of the small intestine, their outer membrane actually is highly folded into what are called microvilli, and these give a tremendous increase in the surface area for absorption. And so let's take a look. We're looking for 4 particular items here. We come back up to our notes to do that. Here's 1, here's 2, 3, 4, 5. Notice that I'm linking the feature to a way in which it's actually achieving that function. And so we've actually got more than enough information here to satisfy the 4 components required for the examiner to give you 4 marks. And I'm sure that you did very well on that question. Again, a classic question from IGCSE biology exams. On to question 5.